Today we're going to find properties. We're going to use properties of congruent triangles and prove triangles are congruent by using the definition of congruent. So if you look back there, see our essential standards. We're on essential standard 4 right now, and the title is literally congruence in triangles. So today we're going to dig into that. So starting off, go ahead and take a second and read this definition. We've known the definition of congruent for a long time. It means two things are the same shape, the same size. So if two triangles are congruent, that means the triangles are the same size. It's the same size triangle, okay? And we find this out by finding corresponding parts. How many parts are there of a triangle? If you have a leg and an arm and a nose and an ear, how many parts does a triangle have?
3.
6. Why 6? There's 3 angles and there's 3 sides. So there's 6 parts of a triangle, and triangles are congruent if all 6 parts are the same. And we call these corresponding parts. And we've actually seen the word corresponding before. When did we see that word before? Corresponding angles. And corresponding angles were in the same place in the diagram. So like the top right corner and the top right corner, right? Those were corresponding angles. They were both on the same side of the transversal, and they were both above their parallel lines. So corresponding means they're in the same place or the same position. So take a look at these 2 triangles right here. If this was 40 degrees and this was 40 degrees, you don't have this on your notes, and the triangles were congruent, I would say that this angle is corresponding to this angle. It's the same angle, and they're in the same place in both triangles, okay? This side is congruent to this side, so I would say that this side is corresponding to this side, because they're both the shortest side. So we call those corresponding sides and corresponding angles. And if all 3 sides and all 3 angles are congruent, then that means the triangles are the same sides. They're congruent. So let's take a look here. Take a look at this diagram. We have congruent polygons. Now, for our class, we're just going to focus on triangles for now. So take a look at the top here. What do you notice? How many things are marked in this triangle and how many things are marked in this triangle? 6. 3 sides and 3 angles for each triangle. Now, this is really important. Put a little rectangle around this, or star it, or put a smiley face next to it. That's called a congruency statement. And it's very important because it tells you what is corresponding to what. It's in a special order. Can you see how they use the colors so that these are both red, these are both blue, and these are both green? Why do you think they do that? Do what? To pair them up. It shows you that A is the same side as D, or same size. That's why they're listed first. Now, it doesn't matter if they're first, but they would have to be in the same order. So this tells me that B is the same size as angle E, because they're the second letter in each triangle's name. So you have to write the name of the triangle in an order that shows that these angles go together. Does that make sense? So let's take a look at this picture right here. This here, once again, put a little rectangle around it and circle this. Do you have this on your notes?
Yes.
This is called the congruency statement. And every single year on the test, I ask for the congruency statement, and people write IDK. I don't know what that means. This is the congruency statement, so don't forget it. If the triangle is congruent to the triangle, and you have to write it in the special order. So this tells me, so we need to mark our triangles according to the congruency statement. So let's say we didn't have this. Ignore this for a second. Which angle is A congruent to in that triangle over there? D? E? I would say definitely probably not E, because E looks like it's pretty close to a right angle, right? If I had to guess, B is probably the same size as E. Would you agree with that?
Yeah.
They both kind of look like right angles. But what about A? Is it F or is it D?
Well, it depends if the triangle is not isosceles.
It's not. So I'll tell you it's not an isosceles. They're all three different. We don't know, right? It could be D, or it could be F, and it might be like 1 degree difference. Like this might be 41 degrees and this might be 42 degrees. That's why this is so important, the congruency statement. It tells us what goes with what. So what angle is A congruent to? It is D. So put an arcing angle A and an arcing angle D. That's how we know. That's the only way that we know. So the first letter goes with the first letter. So that means that B is congruent to E. So we'll put 2 arcs in B and 2 arcs in E. We don't know if they're right angles, so we're not going to put a square there, but they are congruent. And then F is congruent to C. And that's obvious because it's the only angle that's left. So put 3 arcs and 3 arcs. That's the 3 angles. But there's also 3 sides, right? So now we need to go back and double check our sides. So segment AB, tick mark, is congruent to segment DE. So DE has 1 tick mark. So you can do this for the segments as well. What about segment BC, the second letter and the third letter? EF. So put a tick on EF, or 2 ticks, because we already used 1, and BC would have 2 ticks. And then obviously the only one left is the first letter and the last letter. So AC is congruent to DF. So are these triangles the same size? Yeah, and they said it from the beginning. They said the triangles are congruent. But this is how you figure out what is the same size as what. So on your homework, this is all going to be blank. And it's going to say this is 49 degrees. Find X. Or sorry, find Y. What would Y be? 49 degrees. And the only way you know that is if you go back and look at the congruency statement. A is the same size as B. Okay? Easy enough? We're going to skip that. Find, and I'm going to change the directions here. I want you to find the measure of angle D. That is correct. It would be 49.3 degrees. And how did you know that? Yeah. Congruency statement says A is the same size as D. So if A is 49.3 degrees, they're congruent. Therefore, D is 49.3 degrees. How could I find X now? What side, and this one's pretty obvious because it's in a straight line, but how big should this angle be? Should be 90, right? That half of it. Now it's pretty obvious because it's a linear pair and half of 90 would be, or half of 180 would be 90. But let's say we didn't know that. We know that angle C goes with angle C. And that's obviously the 2 angles that back up to vertex C. So I would set 2x minus 16 equal to 90. And then you could solve really easily for x. Okay? This is a new theorem that's super easy. It's basically one of those duh theorems. And it says, if 2 angles of one triangle are congruent to 2 angles in another triangle, what do you think is going to happen with C and F? Yeah, so literally it's named after. So your word here is kind of. If 2 angles in one triangle are congruent to 2 angles in another triangle, that means the third angles have to be the same size, right? So to show this, let's say that this is 30 degrees and this is 70 degrees. What does C have to be? 80, right? Because it has to add up to 180, and 70 plus 30 is 100. Well, if this is 70, what else is 70? E. If this is 30, what else is 30? D. So if you take 180 minus 70 minus 30, what's left again? 80 degrees. Has to be the same because every triangle adds up to 180. Yep, just common sense. You probably already knew that. But now we have a name for it, the third angles theorem. If you know two angles, you know the third.
I have a question.
Yo.
Wait. Do you kind of make up these theorems, or these actually theorems?
Yep, theorems. All right, so if this is 66 degrees, what else is 66 degrees? W. They're congruent, right? And we could actually find angle S right now if we wanted to. So let's say they asked us to find the measure of angle S. How could we find that?
66 plus 44.
Yeah, so 180 degrees minus the two angles that we know. So what's the measure of angle S? 66 and 44 gives me 110, so it'd be 70. So we actually know that S is 70 degrees. But we're trying to get over to angle V, over in that other triangle. So what's kind of the bridge over to the other triangle? Lexi?
66.
Yeah, or no, not the 66. I'd say the 44. And what do we call these types of angles? They're vertical. So if this is 44, so is this. Well, yeah, we already talked about that one though, right?
Oh.
But literally the bridge, like that they go, like one vertical angle is connected to the vertical angle. That's kind of how we hop over to the other one. And then now we should know V. Because why?
Because they're angles too.
If these are congruent to these, that means the third angles are congruent. So V would be 70 degrees. So these here are the properties of congruent triangles. All right, so take a second, and I want you to read the given in this proof, and I want you to mark it in the picture. So anything that's in the given, I want you to come over here, and I want you to mark it in the picture. Okay? Obviously, the first reason is given. Now, we've found a lot of the information already just by marking our picture, right? We have quite a few pieces marked. Now we just need to go through and state them all in our proof. So our right angles congruence theorem says if it's a right angle, it's congruent to any other right angles. So what are the two right angles?
YWX and YWZ.
Yeah, so now we're just going to say those are congruent. So rewrite it, YWX is congruent to angle YWZ. We marked it in the picture, but now we just actually have to state it in the proof. And that is our right angle congruence theorem. All right angles are congruent. They kind of split the given up. See how they only talked about the right angles? There's a lot in the given, but they're kind of splitting it up as we talk about it. So you can see that step 4 is talking about an angle bisector. So I'm gonna take the bisector given and copy it down here. So YW, segment YW, is bisecting angle XYZ. W is the midpoint. That was another given. So now we're talking about the midpoint part of the given. And what did that tell me about the two halves? If W is the midpoint, what does that mean? XW and WZ are the same size. That's why we put tick marks there. But now we're actually writing it in the proof. XW is congruent to ZW. And why is that? Definition of midpoint. They're congruent because it's the midpoint. So that's the definition of the midpoint. YW is congruent to YW. You're killing two birds with one stone because YW is a part of both triangles. Number 9 was given. So we have now proved that two angles are congruent in one triangle and two angles are congruent in the other triangle. So therefore, the third angles are congruent. So angle X is congruent. And step 10 is just the